AP Stats, what is up? This is great news today. This is our last news section of the year. Can I get a woot woot? Yes. So grateful for y'all. And I'm excited as we go into section 7.2. We're going to transition into that. And yeah, here we go. And so I want to go ahead before I actually do this. Let's get a shot up. What'd you say? Oh! Love it. Love it. Hey, let's get it rolling. I know some of you are saying, yeah, you were due. Yeah, I think I was like 0 for like 30, by the way. But regardless, I hit the shot, so get you some. Let's do this as we get started for today's section 7.2. If for some reason you're watching this video, you either were absent or I'm with my child right now. And so I am pumped about that, but also I want to make sure you're prepared, and so I want to make sure we go through it. So real quick, I want you to take some time, do this FRQ, see if you can look at it. If you get really stuck, what you can do is just kind of Google the first few words of this and then put in answers on it, and it will allow you to see what the answers for A and B are regarding an unbiased estimator of the population parameter, and then also the better estimator of the population parameter as it relates to the information up above. So being the true value is parameter is 75 with the mean being 75. My question is what p hat would allow us to see that this is actually unbiased? So what graph would be there and why? So remember, just as a heads up, where x bar equals mu or as close to mu as possible, this allows us to see that it would be, in fact, unbiased, okay? Fantastic. All right, so do this. Go backwards. Do that real fast. Pause me, and we'll continue. All right, so let's go here. We're going to go past this. You could kind of take off these multiple choice questions if you want to. That way you could kind of look at them together if need be. And we'll rock and roll. We're going to skip this. If I see you in class, we'll do that. But if not, the lesson should be good to go in terms of allowing us to see what we're doing and then going from there. So watch the whole video. We're going to just kind of look at this real quick. As we walk through it, I'd like for everyone to kind of start together on this piece and this part. And if you don't, you might have to wait for a second or two. So if you see someone, maybe they're not engaged, get them engaged, get them involved. Because you're going to need them in order to do this lesson. Hey, real quick, this is our QR code over here. We're going to need this. I'm going to trust that today you can use your phones on this, but feel free to go ahead and use your phones and snap that QR code. And if for some reason you can't see it, I'll kind of come to the link here once we've developed to it. Okay. All right. A large bag of Reese's Pieces has 1,000 pieces. Manufacturer says that exactly 40,000 of the candies are orange. If we select a sample of 50 pieces, how many will be orange? Well, let's talk about a couple things. First off, we have this idea of the population compared to the sample. And we recognize that 40% would be the P, the true P, because of what the manufacturer says about my population event. And so that's just a couple of things as we progress into number 1. By the way, this is a review over chapter 6. So just a heads up, review over chapter 6 a little bit. So let's talk about what type of probability distribution that we are going to identify. So we obviously have the sample here. Let's talk about this idea of what type. So real quick, with bins, attack it real quick and see what type of distribution it is, and then go ahead and identify each. So pause me now, identify each in your group, and here we are. We're back with us. And then we're going to just state what each of them are. So we've got this binary where we have a success, which would be an orange candy, and a failure, which would be anything that would not be orange, right? And we would just identify that there. The N is a set number of trials. So set trials, which in this case would be little n being 50. 50 that are selected. S is our probability. So we would say in this example that our P is 0.40 because of what the manufacturer said. And as we go to independence, we recognize that in 1,000, if I take one out when selecting 50 pieces, we would say that there is no independence because there's no replacement. Okay? No independence because there's no replacement. However, when I look at the little n being less than or equal to 1/10 of big N, where this is 50 is less than or equal to 1/10 of 1,000, since the right side of 1/10 of 1,000 is greater than 50, we can then go ahead with independence. And we call this out here, this is called our 10% condition, okay? So again, if independence fails, that's okay. We can still show this 10% condition to continue forward with this binomial distribution here, okay? Number 2 says, draw a sample of 50 Reese's Pieces using the applet, and how many pieces were orange? We're going to repeat this 5 times, and what we're going to do is we're going to write the values below, okay? And we're going to come back to number 3, which says, write the values on sticker dots, add to the dot plot on the board, sketch the dot plot below. Now, if I am not here, don't use stickers. You can just simply use the right side of the board from where you're sitting. So someone could take the leadership, or you could just do the mobile board, either one of those. And you're going to have 5 different values you're going to come up with. And you could even, if someone wants to take over mine too, you could put those as well on there. But each person will need 5 in order to create a large enough sample to be able to go forward with what we're trying to do here. So we're going to add it to the dot plot and then sketch the dot plot below. All right, so we're going to kind of sketch that and go from there. But just so that you're aware of what this would look like, I'm going to do this. Come here. See here. Cool. All right, so if for some reason you're not able to get the QR code, this is the link up on top, so you could kind of copy that there. But you should see something that looks like this, where we're going to find the number of oranges that are here, the number of oranges, and I think that's what it said. Yeah, did it say the number, how many pieces were orange? So we're going to say, we're going to set this up. So we're going to take one sample just so we see it here. 50 is the number of candies, 0.4 is the proportion. And what we're going to do is we're just going to animate this once. So we've got, so we're going to draw the sample. All right, you'll see it here. And it's kind of fascinating. I don't know, maybe that's cheesy of me. But you're actually seeing the amount of orange and then the amount overall. So out of this, we've got 25 out of 50. Okay, 25 out of 50. Let's draw this again. And I'm going to do this here. You actually can take off the animation, I think. You can like hide it or something. You don't have to do this. So I got 25 and 19. I need 3 more. So you could actually change this to 3 if you wanted to, and you just draw samples, okay? And so 25, 19, and I'll kind of write those down. That way I don't forget. So I put 25 and 19. I got 18 here. Let's see what else. Got 27. I need 1 more. Here we go. And after we do, I don't know why I like the simulation. It's kind of cool. But you could kind of put it in here. But this basically will model something, and it does it by random chance, where you basically can see how many oranges that you get out of the total of 50 that you sample. Okay? So we're going to go to, let me pull this back up there. There we are. So once you do that, I'm going to take all 5 of these. So 25, 19, 18, I think I had a 22 in there, and then a 27. And I'm going to take each of these as a specific dot. And on the dot plot over on the side, just all I want you to do is just kind of go, maybe we start at like 15. And then so 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And it should be like whole values, so no decimals on this. And then you're just going to put a dot at the specific spot. The next person will come and put one up on top, and then we're just going to see what the kind of centers around, okay? So we'll do that there. Remember, as we're doing this, that the dot plot that's created, you should get something that revolves around something like this, maybe not as many dots here, but this right here would be a sampling distribution of size equals 50, right? Because each sample corresponds to 50 that is there. So what does each dot mean? Well, if I were to look at one dot here, where I think this would be like 9. So let's say I was looking at this dot right out here. We'll say that that's 0.59, 0.58 maybe. All right, so that dot means that in a sample of size 50, n equals 50, the mean, x bar, or not, well, here's the thing. This is my fault. We're talking about proportion. So the p hat of the proportion of oranges is 0.58, okay? And that's how we would write it there in terms of the sample overall, okay? And so that's what we're looking for. But when we look at ours over on the other side, you'll notice that this would correspond, this one dot for ours would correspond to the number of oranges of one sample of size 50, okay? So a little bit different depending upon how you look at it here. The one we're looking at is more of the number of oranges from a sample of size 50. So we're looking more at the mean. This is more proportion. So note the differences that are there, okay? Ours wouldn't be as much of that. So we did number 4. What is the mean that is in the standard deviation of the distribution? Well, we already said that this is a binomial. So we've got standard deviation of x and a mean of x. And once we plug this in, we get n times p, which is 50 times 0.4. So the mean should center around 20 when you look at that on your graph as far as the number of oranges that are there. And my standard deviation would be a value of 3.46. So typically it would vary by 3.46 away from the mean of 20, or the expected value of 20. So number 6 says, what is the approximate shape of the sampling distribution for x? Explain and sketch it below. Well, when we look at this, we recognize that, remember the normal condition, the law of large counts, that says, okay, law of large counts. Because we say the law of large counts is true, where n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10, we can approximate a normal distribution from a binomial. Or I probably back up, approximate a binomial distribution with a normal distribution. Sorry about that, I kind of flip-flop those. We can use the normal distribution if these are true, and so we could show that by saying, okay, in this case, 50 times 0.4, that is equal to 20, and it's greater than or equal to 10. And then 50 times 0.6 equals 30, which is greater than or equal to 10. And therefore, because of that, we can, in fact, do this part over here, okay? And that's what we're doing on number 6, 6th part. Okay, so let's go to the next thing. We've done that in chapter 6. This was all of the stuff that we've already kind of looked at and looked over. This next part is a little different. We're going to now use our samples from number 2, and we're going to turn each of these numbers into a proportion of orange candies in the sample, okay? So this time, I'm going to go backwards, okay? So my 5 were 2, 3, 4, 5, right? I want you really quick. You're good. You're good, Ryan. I want you really quick to take each of these means that you have here. We'll just write these out, the ones that I have. 19, 18, 27, and 22. And I want you to take them and I want you to create a proportion out of it. So remember, this was out of 50 on each of these. So each of these would actually have not a, wouldn't be like an X bar now, like a mean. We're talking about P hat. So this P hat would be 0.5. P hat would be 0.38. As you can see, it's kind of 0.36, 0.54, 0.44. And so for each of these now, I want you to create a different dot plot over on that right-hand side, where instead of having the mean or the values that you received from the number of oranges, like 25, 19, 18, 27, and 22, this time I want you to write the actual proportions down. So like maybe this is 0.4, so this may be 0.45, 0.5, and then maybe just have values in between, right? And then I want you to actually write it to the right side of the board, especially if I'm not here, and just kind of write that over on the side, sketch it, and then we'll go from there. So go ahead and number 7 and 8. I want to make sure I'm going to address something real quick within my classroom right now, which is stopping the podcast, which is cool. But do this for me. I want you to stop it and then go directly to the one underneath this for the next part. But before we get to 9, 10, and 11, which shouldn't take too long, go ahead to number 7 and 8. Do those in your group, and then put that on the board to your right next to the one with the amount of oranges that you selected as there. All right? Cool, cool. Get it done, and we'll come to the next one. Bye.